Okay, hello everybody. So what we're going to be doing here, okay, we are going to be doing a little review of the foundation science topics. So the way I'm going to format this, I'm going to use my interactive whiteboard here, and I'm going to ask questions as we go along. I'll leave a pause after each question for you to try and answer yourself. You can do it live, or of course you can pause the video if you wish. After the question, I will give you the answer, and then we'll do a little recap of each topic within the unit. Okay, so everything in here will be relevant to your studies, relevant to the exam. Okay, so I suggest you go over this as many times as you need to in combination with your study sheets, and you should be very well prepared for the exam. So we'll start at the beginning, yeah, with the layers of the earth. Okay, so let's start here. Got the middle of the earth, yeah, this big red ball here. Then we also have around this layer. Okay, switch these around so it's a little easier to understand. There we go. Now, can you tell me what these two layers are? We have A and we have B. So which layer is A in the middle of the earth? Good. It is the inner core. And logically, which one would B be? B would be the outer core. Okay? So together, these form the center of our planet. Now, I want you to tell me, what is the total mass the inner and outer core make up of the Earth? Good. Together, the inner and outer core account for about 30% of the Earth's total mass. Now, there's something else we need to discuss. The inner and outer core are both in different states. So the inner core is, of course, solid. Okay? Why is it solid? It is solid because it is under immense pressure from all of the material on top of it. Now, around the inner core, we have the outer core, which is molten. Okay, the pressure is not as great, but the temperature is still very high, so it is a liquid. Okay, now I want you to have a think. Do you remember what the most common metals in the inner and outer core are? The most common metals are iron, okay, and nickel. Okay, so iron and nickel, these two metals comprise most of the inner and outer core. Now, let's hide all of this for a second. Okay, the core is, of course, very hot. Yeah, there's a lot of heat coming off it. All right, about 7,000 to 8,000 degrees. There are 3 reasons for this heat. I want to see if anyone can tell me why. I say anyone like I'm talking to the class. I'm just talking to you, whoever's watching. So, number 1, the inner core, okay, it has radioactive material, okay? Heavy isotopes, things like cobalt and uranium, they sink into the core. They are radioactive. Radiation produces heat. Number 2, something to do with it being at the center. Good. The pressure and the gravity cause it to produce heat, as all of the materials slide over each other, causing friction. And the last reason, you have to go back a long way, if you remember, it is because there is what we call residual heat. Okay, so when the planet was first formed, it was a very, very violent process. You had meteorites and asteroids crashing into each other, and they were incredibly hot. All of that heat got trapped into the center of the Earth, and to this day, it's still being released. Okay? So these three here are the three reasons why the core produces so much heat. Now, let's get rid of these. We don't need them. So, again, we did the middle. Yeah, we had the inner core. Okay? Then we had the outer core. Good. Then there is another layer. Can anyone? So I'm so used to being in front of you all in a class. Can you please tell me what the next layer is after the inner and outer core? Good. It is the mantle. Okay? I know that we usually do it the other way around, from the top to the bottom, but this time we're starting at the middle of the planet, just to kind of get you used to the idea of naming them in different orders. So, the mantle, as you can see, it makes up most of the planet. Okay? What is the total mass the mantle accounts for? Good. It's about 70% of the Earth's mass. It's the largest part of our planet. Yeah? And the mantle is formed from molten rock, which we refer to as, that's right, magma. Okay? Sometimes this magma manages to find its way up to the surface when it erupts out of volcanoes. At that point, the magma changes composition, and we refer to it as, good, we refer to it as lava. Okay? Now, on top of the mantle, we have plates that are floating. Okay? They are not one big solid piece. Okay? They're all broken up into big plates. This layer is known as the, good, the crust. Okay? So we have the mantle. Okay? And then on top we have the crust. Right? The part of the Earth that is hardened and cooled down. Yeah? So, these plates, because they float, sometimes as the mantle underneath moves around, the plates also move around, which means when two plates collide, one might slip under the other, one might go above the other, sometimes they might even just rub together. Obviously, rock is not very smooth, yeah, it's jagged, it's bumpy, so eventually tension builds up. It builds up and up and up and up, and then suddenly one of the plates will move very violently, causing an earthquake. Okay? And that's where our earthquakes come from. So, going back just a bit, when we look at the mantle, okay, remember it's molten rock, it's moving. It's getting heated up here near the core, coming up to the surface, cooling down, and sinking again. So the temperature can vary a lot. Can you remember the temperatures you will find in the mantle? Good. The mantle varies, okay, between about 500 to 2000 degrees. Okay, oops, my mistake. There we go. Depending on where you measure it, yeah? It's going to be hotter here than it is here. Okay? Now, let's go back just a little bit. Make some room. Another thing you will need to know for your exam is what the most common elements you find. What are the most common elements you find in this area, the mantle and the crust? The most common elements on the planet itself. There are 4 that I would like you to use in your answer. Okay? But if you can't remember them all, I'm sure you'll still be able to get... what am I doing? I'm sure you'll still be able to get a good mark. So 1 is, if you can try and think of them before I answer. I'll give you a hint for the first one. It's very reactive, so it binds with most elements. It is oxygen, okay? Oxygen is not just in the air, it is also in metals and rocks. It binds with them. There is a lot of oxygen on Earth. Second one, speaking of metals, it is magnesium, okay? Magnesium is a very common metal in the mantle. And another very common metal, aluminium, okay? And lastly, you'll find a lot of this in sand, silicon, okay? These are the 4 main elements that our planet is made from, all right? Now, if you do answer iron or carbon, those are not in the top 4, but I will still give you the mark, okay? But the 4 I'd like you to try and remember, these 4 here, okay? Now, just one little thing that's relevant to this, okay? Gonna go back, let's just delete the layer, that'll be faster. So, we're just gonna go back a bit. Remember, we're talking about how the Earth, okay, it's got this big crust up here, and then inside, there's the mantle, yeah? Then at the very centre, we have the, come on, there we are. We have the outer and inner core, yeah? Now, obviously, the materials that you find around here, yeah, near the core, they're going to be heavy, dense materials that sink. So, they're going to be more rare up here near the crust, where you will find the lighter materials, okay, that like cool temperatures. So what happens is sometimes this mantle will get really hot. It will carry these rare materials up to the surface where you get things like volcanoes, okay? Which means when you get things like volcanoes and they cool down, all of the lava here will be full of rare elements, things like uranium, things like titanium, okay? Things like platinum, gold, okay, etc., etc. You don't need to remember the exact elements. All you need to remember is that around volcanoes, where there's lava, you will find rare metals and materials from deeper in the planet, okay? And for that reason, that's why you will usually find things like mines, okay, around volcanoes. Now, I think that is everything we need to do for layers of the Earth. So we will move on to our next topic, which is how our bedrock gets broken down into sediment. So we start off with our big rock. Yeah, okay. Here's our rock. Happy little chappy. Yeah. Now, over time, our rock, he's going to become sediment, all right? Sediment could be, let's say in this example, sand, okay? Our big rock, over the years, has been broken down into sand, all right? Tiny little grains. Now, the question is, how does this happen and what happens afterwards? So, first of all, point 1. A certain process needs to happen to our rock. Do you remember what it is? The process that breaks rocks down? Good. It is weathering. Okay? So, I'm going to hide these. Start a new one up here. Okay? Because we need to talk about weathering for a little while. So, weathering breaks rocks down into what? Good. Into sediment. This is the word we use for things like soil and sand. Okay? There are 3 types of weathering. Number 1. See if you can think of the 3 types. Okay. We have biological weathering. Okay. We have physical or mechanical. You might hear it referred to as both. Physical or mechanical weathering. Number 3, we have chemical weathering. Okay? Now, back to weathering. Okay? Let's start with number 1. Let's look at biological weathering. Have a think. Can you think of any ways that biological organisms could break down rocks? Okay. One way. Yeah? Oh, that colour's a bit bright. Let's change it. There we go. One way is plants. Okay? So, I have my rock. Yeah? And my rock, he has a little crack in him. Just up here. Just a little one. Okay? What might happen is eventually a little seed might plant itself in here. Okay? Over the years, my seed will grow and grow. Yeah? As he grows, he's going to make more room for himself. Yeah? So my poor rock is going to start feeling a bit stretched. Alright? As the plant grows bigger and bigger and bigger, hey, it looks like it's got a little piece of hair. That's cute. As my plant grows bigger and bigger and bigger, the roots are going to dig deeper and deeper in. They're going to pull my poor rock apart like this. By the end, after, let's say, I don't know, 20, 30, 40 years, my poor rock is just a pile of sediment and rubble in the ground. Yeah? Because what's happened is he's been pulled apart over the years by all these roots. Okay? But it might not just be the plant doing this. The plant is just pulling them down into little bits. Alright? Those little bits might be getting broken down even further by other forms of biological weathering. So, as well as plants, can you think what else is a form of biological weathering? Something that might also be breaking the rock down at the same time. Good. We also have bacteria and animals. Okay? So, bacteria living on the plant's roots. Alright? They will also produce chemicals that break down rock for food. They will help speed the process up. And as well as the bacteria, we could also have little animals. Okay? So let's say we've got a little rabbit. Okay? He sees this, he thinks, oh, this would be a nice home. Okay? He digs holes in there, he breaks it apart, and over time, got little rabbits and stuff in here also making the rock into a home, breaking it down even more. Okay? There is one last one as well. What would you say it would be if it was something like mining? It would, of course, be humans, who are biological. So humans are also an example of biological weathering. If we decide there's stuff in rocks that we want, whether that's for building or for the materials, we will break them apart. So things like mining, building, okay? These are all forms of biological weathering. Plants with their roots, breaking rocks apart, bacteria and animals, dissolving and breaking rocks apart, and humans, mining rocks. Okay? Number 2, second type of weathering. We have physical weathering, okay? Or mechanical weathering. There's 2 main ones we're going to look at here, okay? A, when it's really cold, do you remember which weathering type we get? Good. It is freeze-thaw. Okay? Thaw means to melt. So what's happening here is, again, we've got a boulder, yeah? Our boulder, okay, he has a little crack up here on the top, yeah? When it rains, some of this rain trickles in, okay? But then, when the weather gets cold, okay, so the temperature goes really low, yeah, what's going to happen to the water in my boulder buddy over here? The water is going to freeze, yeah? When it freezes, what's going to happen to the water? This water here, when it freezes, it expands, okay? It gets bigger. As it gets bigger, pushes the cracks further apart, okay? So these cracks, they're going to widen, they're going to get deeper, yeah? Eventually, this process happens again and again and again. The water gets deeper and deeper, the cracks get wider and wider, and by the end of it, of course, my poor boulder has been cracked in half, broken apart, and the process is going to keep happening as new cracks form, okay? So that's freeze-thaw weathering. It happens in cold places. Then, let me just rub this off. The other type of physical weathering that we looked at is one that happens in hot weather. We call it day-night weathering. Okay. Multiple names, but I'll know what you're talking about. So, this one is where I've got my rock. Who knew you could talk about rocks for so long? Isn't it fun? So, we've got our rock here, yeah? It's a sunny day in, let's say, the desert, okay? As the sun shines on our rock, his outside starts to get a little hot. When it gets hot, the outside layer of my rock, okay, all of this, starts to push outwards and expand, okay? Now, again, nighttime comes, alright? The weather cools down. As it cools down, the outside of my rock is going to do what? It was expanding, now it's cold, it's going to contract, okay? So the outside that was hot is now contracting, yeah? It's all moving in. The problem is, the center of my rock is still a bit warm, okay? So this one is still pushing outwards a bit. Obviously, when you've got something pushing against something else, it's going to cause stress, yeah? As the outside is trying to go inwards and the inside is trying to go outwards, you start to get little cracks form where the two parts meet, yeah? Over time, this repeated squeezing where they're both pushing against each other, the outside and the inside, is going to equal cracks and breakages, and your rock will slowly start to shed off layers that will pile up around it as sediment. Now, very quickly, let's go over number 3. Okay, chemical weathering. Okay, so chemical weathering. Okay, let's get my rock down here. Yeah. If you think back to semester 1, we talked about things like sulfuric acid. Okay, when we have factories causing pollution, they send things like sulfur into the air. In clouds, that sulfur combines with H2O, water, and it forms what we call acid rain. So, when the clouds rain a bit, some of that rain is acidic. Yeah? Now, there's lots of different types of rocks. Some of them are made from things like limestone, which, again, back to semester 1, is calcium carbonate. If you remember, carbonates produce 3 things. They produce a salt, they produce CO2 gas, and they produce H2O. You do not need to be a genius to understand that these 2 are not rocks. Yeah, CO2 and water are a gas and a liquid. So, what's going to happen to my rock made of limestone when this reaction here happens? It's going to... That's right. It's going to melt. Okay? And parts of it are going to wash off in a little slush, like a slurry. Okay? So, my poor little rock here slowly melts away, leaving behind nothing but a little bit of salt and a little puddle of water, and the rest of it escapes as gas. Okay, so those are the 3 forms of weathering that we have looked at. Now let's look at the final 2 things. We had weathering, okay, and we had the part where our rock moves somewhere else. The sediment gets moved. We refer to this as erosion. Yeah. Now, erosion is mainly caused by water. Things like rivers and rain wash sand and sediment and soil away. What else can move sand, sediment and soil away? Think about times it might get in your eyes. Wind. Yeah? The wind will blow things like sand around. You'll notice it can get very dusty here and it will build up on things like cars. That's where sand has been eroded from somewhere else, blown away, and then dropped here, which is the 3rd part we'll talk about in a minute. And of course, gravity. Yeah? Sediment will sink if it's on top of an ocean or a mountain or something. Now, number 3 I just mentioned. When it gets dropped down, we call that deposition. Okay? It is being dropped elsewhere. So, weathering is to break down. Yeah? Erosion is to move, and deposition is to drop. Okay? So, we'll do very quick, because I'm aware we need to get on to the next topic. Very quick start to end, yeah? Let's say we've got a mountain here, yeah? Mountain range. So, weathering, let's say freeze 4, okay? Breaks the rocks on the mountain down into sediment, yeah? There is a river running underneath the mountain. The sediment gets swept into the river. That would be erosion. Okay? The river carries the sediment to the end. Alright? When the river ends, it meets the sea. Yeah? And the river slows down. Okay? As it slows down, all of this sediment, okay, all of this sediment that was in the mountains gets dropped. Do you remember the word we use? Come on. Good. We call it deposition. Yeah? This results in landforms like deltas, okay, islands at the mouth of a river, or it can result in landforms like beaches, yeah, where the sand from all the way up here is getting dropped off all the way down here. So weathering breaks it down, erosion carries it somewhere else, deposition puts it down, okay? Right, I think that's everything we need to cover for this. So, let's move on, okay? The second half of the foundation science topic was renewable and non-renewable fuel sources, okay? This is what we did for the second half of the unit, if you remember. So, I would like you to tell me, what is the difference? Okay, sorry. What is the difference between a renewable and a non-renewable? It's in the name. Good. So, renewable fuel sources are energy sources that can be replenished. Okay? We can replace them. It's a bit like recycling, alright? You can just keep making more over and over and over again. Yeah? They're not going to run out. So, I'm sure you can figure out from that what a non-renewable energy source is. It is, of course, energy sources that... My apologies. There we go. Energy sources that can run out. They are finite, the opposite of infinite. Okay? Once they're gone, that's it. They're gone. Okay? So, we're going to start with the non-renewables. Yeah? Again? There we go. So, we'll start with our non-renewables, alright? When it comes to energy, typically, when we talk about non-renewables, we're talking about fossil fuels, okay? Have a think. Can you tell me the three main fossil fuels that we use? Good. They are coal, oil, and natural gas, or gas for short. Okay? If you say just gas, I'll know what you mean. So don't worry about the natural part. If you forget to put it down, I'll still understand you. So, let's look at why they're so useful. Why do we use them? There's a few points. Point one, what do we mainly use them for? Good. We mainly use them for energy. Okay? But why? Why do we use them for energy? What makes them so good at it? There's a few reasons, okay? So, reason one, they are energy dense, okay? They produce a lot of energy, yeah? Let's say this is fossil fuels, okay? The equivalent, okay, of renewables, let's say you're burning trees, okay, instead of coal, it's going to be a lot less, yeah? You get a lot more energy from fossil fuels per gram than you would from something renewable like a tree or ethanol, okay? Second reason, they are convenient, yeah? You can just dig and burn, yeah? You dig them up, you process, and then you can burn. They're easy to move around, they're easy to carry, they're easy to burn, yeah? Makes them very convenient, okay? And number three, they are, of course, reliable, yeah? You can use them anytime, anywhere, whenever you want, okay? You don't have to wait for anything. You can take that coal, you can dig it up, take it wherever you want, and burn it when and wherever you need it. So, they are very useful. But now, we have to look at the bad side, okay? Fossil fuels equals bad. Why? Okay, everything we just said over here, these are all good things, yeah? Energy dense, convenient, reliable, these are good. So why is there a problem with using fossil fuels? Well, first of all, it's in the name. Remember, fossil fuels are what? Non-renewable. Okay? As useful as they are, they will run out. We can't rely on them forever. But it's not just this. They also produce things. What do they produce? Good. They produce pollution. Okay? Pollution, things like PM25. Okay? 25, sorry, PM2.5. Particles, they produce things like sulfur dioxide, nitrous oxide components, carbon monoxide. All of these are very bad for your health, okay? And it's not just the pollution they also produce a specific gas, CO2, which causes global warming. Okay? Now, global warming is very bad. Can anyone have a think? Because this might be relevant to exam. What can global warming do? It can cause rising sea levels. Very bad if you're an island. Okay? It can kill crops. Okay? Very bad if you're a farmer. And it can kill animals. Very bad if you like to eat things like fish, because it kills animals in the ocean particularly. Okay? So, we know fossil fuels are bad. Okay? And the answer is to get away from them by using renewables. But first of all, let's have a quick discussion about what fossil fuels are. Okay? We know why they're good, we know why they're bad. Now we need to look at why do we use these things. So, coal, oil, gas, they all have one thing in common, which is what? Good. They take millions of years to form. Okay? They all have that in common. Now, that is because they are made from what? Good. They are made from, again, they are made from prehistoric organisms. Okay? Oil and gas are made from, good, sea organisms. Okay? These are things like plankton. Okay? You ever watch SpongeBob? You'll know what that is. And coal, on the other hand, is made from, good, plants. Okay? Plants that would have grown in swamps or marshes where they were very quickly covered by sediment when they died. This is why you will not find coal or oil in the same place. Because, do you mind? Because one grows on land, the other is from the ocean. Okay? So you won't find them together because they grow in different environments. Now, we also need to look at other uses for them, okay? Because it's not just energy. So coal, as much as we use it for energy, do you remember what else we use it for? Good. We use it in the steel industry, okay? To make steel from iron. Oil. Again, even though we burn it for energy and for vehicles, we can use it to make something else. Good. We use it to make plastics, okay? We also use gas to some extent, okay? And oil and gas we also use to make chemicals for things like factories, okay? This is because all three of them have a very special property. They are made from a very special type of molecule. Do you remember what it's called? It's called hydrocarbon, okay? These molecules are carbons and hydrogens. They are very useful, not just for energy, but also for making plastics, chemicals, and steel. Yeah? So it's not just energy, they have other uses too. Now, last thing with the fossil fuels before we move on to renewables is each one's specific positive or negative. So, coal, positives are it's cheap, okay? So it's what we use to make energy, mostly in power plants. The negative is a lot of pollution, okay? It does not burn cleanly. There are also different types of coal. So we have lignite and anthracite. Okay, these are the main types you need to remember, these two. Okay, we burn different types of coal, but the thing they all have in common is they are cheap, but they make a lot of pollution. Alright? Now, if we look at oil, okay, oil, the advantages, it's very versatile, okay? We can make a lot of things with it. We can make plastics and chemicals. The negatives are, again, pollution. It makes a lot of pollution. Okay? Then we have gas. Okay? So natural gas. The positives are that it makes less pollution than the others. Okay? It burns more cleanly. It is also very convenient for things like cooking and heat, to heat your home. Okay? The only negative is it's a bit more rare, okay? It's a bit harder to find than the other two. Now, I think that covers everything you need to know about the fossil fuels, alright? So, let's move on to our last one. Look, we're already nice and green. The last one is, of course, renewables, okay? Yeah, I don't want that one. So, renewables, okay? As we said before, these are sources of energy that will not run out, okay? Can be replenished, replaced, yeah? So, there's a few types. I want to see if anyone can tell me the types. Number one, if I grow it, okay, let's say I grow wheat or rice or sugarcane, what type of renewable would this be? Good. It would be biomass, yeah? So I can either grow crops to turn into biofuel, or I can take the waste from things like rice farming and burn it, yeah? Number two, let's say I build a big dam, okay? And I run water through a turbine to make energy. Do you remember what type of energy this would be? Good. It would be hydroelectricity, okay? We'll just cover the main ones, alright? Number three, energy that I get from the sun by letting it shine directly onto a solar panel. What's this type of energy called? I just said the word a minute ago. It is, of course, solar energy. And four, let's look at one more. If I have a turbine and it's blowing, this is, of course, an easy one, wind energy. Yeah? There are other types of energy as well. We have five, just one quick last one, energy that we take from underground near the mantle. Remember, it makes heat. We would call this geothermal. Okay? So, with renewables, as you can see, there are lots of options, whether it's biomass, hydroelectricity, solar, wind, geothermal. There's even more than that. We can have wave energy. We can have hydrogen fuel cells. Okay? There are multiple types of renewable energy suitable for different needs. But the problem is renewables are not as convenient as fossil fuels, okay? They all have advantages and disadvantages. So, if we look at something like solar and wind, obviously, what's the problem with these two? That's right, they are unreliable. Okay? They rely on the weather. If the weather is bad, you're going to have no energy. On the flip side, hydroelectricity. Can't spell. Hydroelectricity and let's say geothermal. Okay? These are very reliable. But they have a different problem. Can anyone guess what it is? Good. They are very expensive. Okay? So, if you want something that's reliable with renewable energy, you're going to be spending a lot of money. Okay? Now, the good thing about most renewables is that they do not cause pollution okay? And even more importantly, no greenhouse gases, okay? Now, biomass, okay, does of course cause greenhouse gases because you're burning stuff. But you have to consider, okay, all of these gases, if you're using biomass, where are they going to go? It's CO2. It's just going to go back into growing more biomass. So it's a nice little loop. Yeah? So most of them, if done properly, you're going to have no pollution, no greenhouse gases. Okay? Now, having said that, what is the big disadvantages of renewables as a whole? Why is it hard for us to move from fossil fuels to renewable energy? Good. 1, they produce less energy. Okay? Burning fossil fuels makes a lot of energy. We're used to that amount of energy now. So if we suddenly stopped using fossil fuels, it wouldn't meet our energy needs to just use renewables. Okay? Number 2, they are less convenient. Yeah? They are less convenient because they take more time to build or process. Okay? And they are hard to move. Yeah? With oil, you can just put it in a can. Take it somewhere. Take it to a plane. Yeah? Take it to a car. Alright? With something like electricity, you either need to charge the device, so it needs to be near a power plant, or at least connected to it, or you need a battery. Yeah? Obviously we can solve these, okay? But the main thing is we don't have enough time, okay? So, the direction this is going, you might be able to figure out. As we transition from fossil fuels to renewables, we need something in the middle, because we need to give ourselves some more time to build renewable energy sources. Okay? Can you guess what the bit in the middle is? Good. It is, of course, nuclear energy. Alright? So, some countries, what they're doing is they're using renewable energy to fill this gap and buy themselves more time. Okay? So, nuclear energy. Okay? Let's talk about it a bit. You should have this on your study sheet, but we'll go over it again very quickly. Alright? Nuclear energy is caused by nuclear fission of heavy isotope elements like uranium. Alright? This is useful because it produces... Actually, let's use black. There we go. No, let's use blue. There we go. Lots of energy. Yeah? 2, another reason it's useful. Can you think of one? Good. It is very reliable. Yeah? As long as the reactor is burning, we will have energy. And not only that, we can, to some extent, control it as well. We can control how much energy we make with a nuclear power station. If we need more, we can pump up the reaction. Number 3, no pollution or greenhouse gases. Okay, no CO2, no pollution. All right, so it's very useful for moving from fossil fuels to renewables, because the whole reason we're trying to switch from this is to get rid of CO2, okay, and stop global warming. So if we have an energy source that produces lots of energy and is very reliable, but also doesn't produce CO2, that's perfect for us. So why are we not all using nuclear reactors to solve our problems? Because, one, they are expensive, okay? They are expensive because of the safety. To build them, to maintain them, to shut them down properly costs a lot of money, okay? Number 2, nuclear waste. This isn't a big one, but it is worth considering. The very small amount of nuclear waste they produce is very dangerous, yeah? And it won't be gone for a very, very, very long time. It stays dangerous for a long time. So we need to consider how much waste we're making and where we're storing it. And then number 3, another one, is that not suitable for every country. Yeah? Some countries won't sell uranium if they think the other country has bad intentions. Yeah? If they're looking at a country and they're going, I think you're going to use it to make, let's say, a bomb, yeah? They're not going to give them any uranium, and rightly so. So, nuclear power is very useful. It can help us bridge the gap, but there's only certain countries that are going to be able to use it, because there's only certain countries that are going to have the money and the technology and the allies to be able to use it properly and safely. Okay? So, all in all, I think we've covered everything there. Okay? We know that we need to move from fossil fuels to renewables. Okay? We know the challenges we face, the energy gap, and the time. And we know the solutions. Okay? Putting more money into renewables, and if available, bridging the gap with nuclear power. Okay? So, I believe we've covered everything in the topic. Let me have a quick think. I'm right. Yes, we have covered everything in the topic. So this is all the foundation science. Again, feel free to go through this video, pause it, use it for your studies, use it with the study sheets. Please use the study sheets. If you know everything on the study sheet properly, you will be fine in the exam. Okay? And most of all, if you have any questions, if you aren't sure, if you're worried about something, just come and talk to me, come to the office, ask for me. I'm always happy to help, okay? And with that, I wish you the best of luck. I'm sure I'll see you before the exam anyway. Good luck revising, good luck studying, and see you all soon. Work hard, guys. Bye.